Okay, so this week we're going to move on to more complex differentiation. We're going to be looking at how you differentiate when you have a product of two functions, and also how you differentiate when you have two functions divided, or one function divided by another function, the quotient rule. So let's, again, the best way to deal with this is to just look at an example. Say you had a function like this, x squared cosine, so that's 3x on the top, x squared cosine of 3x. Now with the rules we have so far, even including the chain rule, we cannot differentiate this function, because this is actually a product of two functions. It's a product of x squared and it's a product multiplied by 3x. So the way you do this is you say that that's equal to, you let x squared equal what we call u, and the cosine of 3x we call v. So explicitly u is equal to x squared, and v is equal to cosine 3x. Now this is a product, and what you need to know is that there is a formula or a rule for differentiation of product. So what you want is you want dy by dx, and what the product rule differentiation says is that dy by dx is equal to u dv by dx plus b du by dx. So you should try to remember that. And what we're going to do now is we're going to give specific examples of its use. So what we need to do now is work out each of these. We have u defined up here as x squared, and we have v defined as cosine of 3x. So we know u and v. Now we want dv dx and we want du dx. Well, u is x squared, so du dx is equal to 2x. We can do that. And dv by dx, we know that from the last week. We can work the chain rule, or we can do it by inspection. It's going to be minus 3 sine of 3x. So now, all we have to do is we have everything for this formula here. So the product rule says dy by dx is equal to, so u is equal to, up here, u is equal to x squared. And you have to multiply that. Now I'm going to use a small dot here as a multiplication. Sometimes you can use a cross sign, I can use it already. But the small dot just is a little bit neater, so I'm going to use that as a multiplication sign. dv by dx, here is minus 3 sine 3x, so that's multiplied by minus 3 sine 3x, and then you add v, and v is equal to, up here it's cosine 3x, and that's multiplied by du by dx, and du by dx is equal to 2x, and again we use our dot for the multiplication, 2x. So sometimes you would like to tidy up that expression. That is an answer in its own, that's fine. But sometimes if you maybe have to do say you have to differentiate this twice, sometimes it's nice to tidy up the expression. And what you do is you look for a common factor that you take outside the brackets. So if you inspect that, you'll find you could take x outside the bracket, and that would be x then into minus 3x sine 3x plus, take the x out here, so it's cosine, or 2 times cosine of 3x. And that just looks a little bit neater. Right, so again, let's the way you learn these is by examples. So again, say we had this product, x cubed into 4 minus x to the power of a half. So again, this is a product. So you write it, y is equal to u times v. And that u equals x cubed, and v is equal to 4 minus x to the power of 1/2. So now we need to know that our formula, we'll need to know du by dx, which is equal to 3x, and dv by dx. And again, we would have to use the chain rule for this. So you're going to be, from last week, it's dy by dx is equal to du by dx multiplied by the y by du. So u here would be, you'd put it equal to 4 minus x. So u du by dx would be equal to minus 1. And then you'd have to multiply that by, you'd have u to the power of a half. So you'd get a half u to the minus a half. And u is equal to 4 minus x. So it's u 4 minus x to the power of minus a half. So again, if you can't understand that, you need to look back, how to come up with that, you need to look back at last week's lecture on the chain rule. So now we want to differentiate the product here, so we have to write down what the product rule says, that the y by dx is equal to u dv by dx plus v du by dx. So we have to plug in our values. So v, let's look back up here, v is equal to x cubed, is equal to x cubed. And you have to multiply that, again we use the dot for the multiplication, by dv by dx. Well, dv by dx is this figure here, so that's minus a half 4 minus x to the power of minus a half. And then it's plus, so here now, plus v, which v is 4 minus x to the power of a half, du by dx. And du by dx is equal to, square. So we can simplify that a little bit, and we say that that's equal to minus x cubed over 2 to 4 minus x to the power of 1/2 plus 4 minus x to the power of 1/2 times 3x squared. Now again, this is fine, this is fine as an answer, but again, if you had to differentiate this again, it might be worthwhile trying to clear it up. And what you can do is you can consider these as two fractions, so you could add them together. So if you did that, then you would have below the line, you have this value here, so you'd have 2 into 4 minus x to the power of a half, and if you divide that into that, you get 1, so you get minus x cubed on the top, and then you get, if you divide that into 1 into that, then you multiply by that. Here you have 4 minus x to the half, here you have 4 minus x to the half, so the half plus a half is 1. So you'd end up with, and the 2 multiplied by 3 gives you 6, so you get 6x squared into 4 minus x, because the half and the half together gives you 1, so it's 4 minus x to the 1. And again, if you wanted to, you can simplify that. You can take an x squared outside, and if you rearrange the figures inside, you get 24 minus 7x all over 2, 4 minus x to the power of a half. So that's in a nice, neat form, if you like. So if you had to work with this again, it would be easier to do it. But the main thing I want to teach you here is how to get to this stage. Right, so if we move on to another example, and here we have a function y is equal to 1 minus x cubed e to 2x. So now again you have u, let that be a u, let that be a v. So you let u equal 1 minus x cubed, and you let v equal e to 2x. So now du by dx is equal to minus 3x squared, and dv by dx is equal to, again, you should know this from the last week, is 2e to 2x. So now we use the product rule, so there's a dy by dx is equal to u dv by dx plus b du by dx. So again, like we showed last week, we just have to plug our values into them. So that's equal to v, or u, sorry. So that's u there. Our u's right. It's u, which is 1 minus x cubed. So it's 1 minus x cubed multiplied by dv by dx. dv by dx is 2e to 2x. That's plus v. v is e to the 2x. And that's multiplied by, in brackets, minus 3x squared. And that's it, essentially done. And what you can do here, if you want to tidy it up, is common factor here is e to 2x. So you take that outside the brackets, e to 2x, and that then goes into 2 minus 2x cubed minus 3x squared. And sometimes it's nice to just arrange the powers in the correct order. So you could say that's 2 minus 3x squared minus 2x cubed. Again, I'm not too worried about this tidying up bit here. The main thing is that you understand the product rule and you know how to get to this stage. And it's a nice little exercise to try to tidy it up a little bit like that. Right, so that's the product rule. That's when we have two functions products of each other, and that's the way you differentiate a product, and you come across a lot of products in chemistry applications, as you'll be seeing in the exercises that I give after this lecture. But the next one we have to do is quotients. All right? So what do we mean by that? So say you're given a function y is equal to cosine of x divided by x squared. And it's a similar procedure you use. Again, you use that it's, you identify cosine x with, say, u, and you identify the x squared with v. And again, you have a formula that you need to use. And this is called the quotient rule. It says dy by dx of a quotient, u over v, is equal to v du by dx minus u dv by dx, all divided by v squared. So again, the best way to look at it is an example. So let's take our first example. So you have, as we've shown above there, y is equal to cosine of x divided by x squared. And as we said above, that's equal to u divided by v. So u is equal to cosine of x. V is equal to x squared. Du by dx is equal to minus sine x. And dv by dx is equal to 2x. So now we use our formula from above. I'll write it down again here. So dy by dx is equal to v du by dx minus u dv by dx all divided by v squared. So we've just got to plug in these values there. So it's equal to v, which is x squared, du by dx is minus sine x. So again we use our dot, minus sine x minus u, which is, here u is cosine of x, times 2x, which is dv by dx. And then you need to divide that all over v squared, and v is equal to x squared, so v squared is equal to x to the 4. And that's pretty much it done. So you can tidy up that a little bit again. So again, you can take x or minus x outside, and you get x, it'll give you x sine of x plus 2 cosine of x all over x to the 4. And then you can cross x cubed here. So that would give you minus x sine of x plus 2 cosine of x all divided by x cubed. And that's your solution. Okay? So again, all I expect you to be able to do is get to here. If you want to tidy it up, that's okay. But this is the bit you want to learn. You want to learn what the quotient rule is, how you separate it into u and v, and then plug the values in. Right, let's try another one. So y is equal to x squared plus 6 over 2x minus 7. And again, top one is u, the bottom one is v. So u is equal to x squared plus 6 du by dx equals 2x. V is equal to 2x minus 7. dv by dx is equal to 2. So use our formula again. Dy by dx is equal to v du by dx minus u dv by dx all divided by v squared. So plug the values in, and if you do that, you get 2x minus 7 times 2x minus x squared plus 6 times 2 all divided by v squared, which is 2, v is equal to 2x minus 7, so v squared is 2x minus 7 all squared. And that's it. Done, essentially. Again, I'd like to tidy it up a bit. So you have a 2 common factor here and here. So you can take the 2 outside, and you can make that into 2x squared minus 7x minus x squared. It's minus 6, isn't it? You do the minus sign here. minus 6 all over 2x minus 7 all squared. And we'll leave it at that. Okay, another example using these trigonometric functions that come up quite a lot in chemistry. So you have y is equal to tan of x. Now, where's this got to do with the quotient? Well, you should know from the trigonometry we did last year that tan of x is equal to sine of x divided by cosine of x. So now you have your u and v functions, haven't you? There you go, u and v. So u is equal to sine x du by dx, we all know now is cosine of x. V is equal to cosine of x. dv by dx equals minus sine of x. So you plug these into your formula. So it's, if you remember, it was v du dx, so v is cosine of x. du dx is cosine of x as well, minus u, which is sine x, times dv dx. And dv dx is minus sine x, so it's minus sine of x. And then that's all divided by v squared, and v is equal to cosine, so that's cosine squared x. So if we tidy up, we're going to have here cosine x by cosine x is cosine squared x. And now you have minus minus, so you're going to get plus, and you're going to get sine of x by sine of x, which is sine squared x, all over cosine squared x. And now again, if you remember back, cosine squared of x plus sine squared of x is equal to 1. Which is again something you learned in your trigonometry last year. And that's 1 over cosine squared x. And another bit of trigonometry that comes in handy here is cosine x is equal to what's called sec x. So basically, it's 1 over cosine x is equal to sec x, that's equal to sec squared x. Okay, so you have lots of exercises that you can work on this week on differentiating products and quotients, and that is the way really, the best way to learn this and how to do it and to become familiar with it is to do the practice and the exercises.